Hello! In this video, we are going to prove the following theorem. Let B be a set and F be a family of sets. Then the union of F is a subset of B if and only if F is a subset of the power set of B. Now, given any family of sets F, to say that X is an element of the union of F means that X is an element of some set in F. And given any set B, to say that A is an element of the power set of B means that A is a subset of B. Okay, so now let's get into proving the theorem. Now notice, we're trying to prove a statement containing if and only if. So what we're going to do is we're going to prove if this is true, then this is true. And then we're going to prove if this is true, then this is true. Let's start out by proving if this is true, then this is true. And to do so, suppose this is true. From here, we want to show that this is true. And really, we're trying to show that everything in F is also in the power set of B. So give me an arbitrary element of F. I'll call it A. And now we want to show that A is also an element of the power set of B. In other words, we want to show that A is a subset of B. Which means we want to show that everything in A is also in B. So give me an arbitrary element of A. I'll call it X. Well then, we see that X is an element of a set in F, namely A. So this tells us that X must be an element of the union of F. But since everything in the union of F lies in B, X must also lie in B. So we see that under the assumption that X is an element of A, we have that X is an element of B. Since X was arbitrary, this means that everything in A is also in B. So we have shown that A is a subset of B. And to say that A is a subset of B is the same thing as saying A is an element of the power set of B. And so putting this all together, we see that under the assumption A is an element of F, we have that A is an element of the power set of B. Since A was arbitrary, this means that everything in F lies in the power set of B. So at this point, we have proven if this is true, then this is true. Now we're going to show if this is true, then this is true. To do so, suppose this is true. From here, we want to show that this is true. That is, we want to show that everything in the union of F lies in B. Well, to do that, give me an arbitrary element of the union of F. I'll call it X. From here, we want to show that X also lies in B. Well, since X is an element of the union of F, this means that X is an element of some set in F. I'll call that set A. Well, since A is an element of F, and everything in F lies in the power set of B, this tells us that A is an element of the power set of B. And we know that this is the same thing as saying A is a subset of B. And since X is an element of A, and everything in A lies in B, this tells us that X must then be an element of B. So we see that under the assumption that X is an element of the union of F, we have that X is an element of B. Since X was arbitrary, this means that everything in the union of F also lies in B. So at this point, we have shown that if this is true, then this is true. And we've proven both directions of the if and only if. So we have proven this entire statement. And that's exactly what we wanted to prove. So this completes the proof. And so yeah, that's pretty much it for this video.